Hello class, in this unit we are going to be studying destructive seismic events, those being tsunamis, earthquakes, and volcanoes. Before we start, I'd just like to show you how we're going to be doing the vocabulary for this specific part of the unit. I want you to take your paper and divide it into 4 individual segments, one being for the word, one for the definition, one for putting the definition in your own words, and one for a memory trigger. For example, if the word is cat, the definition is feline. In your own words, it could be Tom of Tom and Jerry. And a memory trigger would be a picture as best you could draw it of a cat. Got it? Everybody say yes. Moving on. Some quick vocabulary. I'm switching pen colors to green. First up, we have disasters. A disaster is a large-scale, uncontrollable catastrophe that can cause human loss, suffering, displacement, and chaos. A large-scale, uncontrollable catastrophe that can cause, and notice, it's not a disaster unless it causes human loss, suffering, displacement, and chaos. Disaster. Next up is seismic. Seismic means pertaining to the vibrations in the earth, such as earthquakes. Seismic is actually an adjective. And we use it to describe a noun, because that's what adjectives do. So if we say, that's a really seismic car, we're saying that's a really earthquakey car. Dude, you're so seismic. Gentleman over there, you quite remind me of an earthquake. So seismic is an adjective. This is important. If you use it as a noun, I will mark on your paper big red no. It is an adjective. Next up comes tsunami, a series of waves generated when a body of water, such as an ocean, is rapidly displaced on a massive scale. By the way, while I have your attention, this is a video. It has a pause button. Be sure to avail yourself of the pause, the rewind, and the fast forward buttons so that you can catch everything that's going on here. Back to tsunami. Tsunami, here, ready? Series. This is big. Series of waves. See that S? Waves. That S goes with series. One wave does not a series make. Multiple waves make a series. It's a series of waves generated when a body of water, well, where else are you going to get waves from, huh? Body of water. Hey, look, waves. Waves in a body of water. Who would have thunk it? Such as an ocean. Ocean's a body of water, right? Is rapidly displaced. Displaced, to help you out, means moved or bumped. Mass is rapidly moved or bumped on a massive scale. In other words, dropping one little pebble into the ocean, not gonna do it. However, Here's our ocean. A subduction zone suddenly shifting downwards. That's massive. Hint, 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 hint. If you do not understand what is happening here in this is a subduction zone. Oh, you know what? I mislabeled something. It's not oceanic crust. It's continental crust. Okay, and now it's not writing correctly. Continental crust. Okay, this is a subduction zone now, right guys? Say yes, yes, this is a subduction zone now. Subducting, the oceanic crust is subducting down, and the continental crust is, of course, not. And they're coming at each other like this. And then here, up here, I drew very choppy ocean waves. Notice, this ocean, no period after it. This ocean, period after it, because it's short for oceanic. And the ocean is on top of it. A subduction zone, which you should remember from last unit, under the ocean, is a massive enough scale to cause a potential tsunami. There's a reason I'm harping on this, and that reason is that today we're studying tsunamis. That said, some more quick vocabulary. We had seismic. Seismic was the adjective. Earthquake is the noun. Dude, that earthquake is so seismic. Gentleman over there. That ground-shaking, radiated seismic energy caused most commonly by sudden slip on a fault, volcanic or magmatic activity, or other sudden stress changes in the earth is so pertaining to an earthquake. Earthquake is a ground shaking. Haha. Get it? Earth. Quake. Quake means to shake. Earth is the ground. Ground shaking and radiated. Radiated means going out from a center. So when you drop a pebble in a bucket of water and you see all those rings going out from the center, that's radiated. The sun, with its happy little rays, those rays are radiated. Radiate, yeah, it's a loose connection at best. But radiated means going out from some sort of center, and this right here is the center. So radiated seismic, haha, we're sort of using a word in its own definition. Radiated seismic, meaning earthquakey. And earthquakey, of course, we know means ground shaking. So ground shaking and radiated ground shaking energy caused most commonly by, this should say A. See, here's my grammar. A sudden slip on a fault, sudden. If it's slow and it's happening slowly, as is a divergent zone, it's not sudden. If it's a convergent zone that's pushing up against each other, kind of not very sudden unless we're talking it got stuck. And here's our convergent zone again. this time I'm writing O and C instead of oceanic and continental. This bit of oceanic, as it's going down, right around here. You know what? I'm going to switch my colors just so that you can see it better. What color should I use? Blue. Right around here. In what we call the subduction zone, right there, that's kind of high friction. And it kind of gets stuck together most of the time. Most of the time it's just rubbing up against each other, like two pieces of sandpaper are rubbing up against each other, and they kind of get stuck. But every now and then, because this is still trying to go. This is very much still trying to go. So every now and then, this piece that's still trying to go pushes ahead in a big jolt. A big jerk. A big chunk goes whoosh. And that creates a sudden slip on a fault. Now, this is a subduction zone. We said convergent boundaries in the last unit. Convergent boundaries have the worst, the absolute worst of the kinds of, the absolute worst kinds of earthquakes. And the reason is, look at all of that mess. Like, it's all this radiating all the way back up. You've jolted it from all the way down here, all the way up through the water, back up to the surface of the Earth, the continental crust, which is way up here in my little not-to-scale drawing. Very, very bad earthquakes. So that's a sudden slip on a fault. Fault being any time two plates come together. Volcanic, that's a volcano. Here's my little volcano. And have some lava. Volcanic. Or magmatic. So what's the difference between volcanic and magmatic? Magmatic could be a divergent zone, where you just have, like, the dike rock forming and the pillow lava. That's an example of magmatic. Jolt needs a T. I backed it up too far. Magmatic activity or other sudden stress changes in the Earth, such as... And now I'm going to give you a hint to guess what my delightful little artwork is saying, such as... a stick of dynamite that goes boom! Yes, that's right, ladies and gentlemen. Man! Other sudden stress changes in the Earth. Man can make his own earthquakes. An earthquake of magnitude 8 or larger, this you don't have to copy down. An earthquake of magnitude 8 or larger is termed a great earthquake. Yay, good for it. And next, a volcano. We all have probably by this point seen volcanoes. There's lava, nasty lava run. Yeah. It's coming out of something. Volcano. A volcano is a geological, meaning made out of rock. Landform, meaning formed out of land or earth or ground or rock. So we have a rock thing made out of rock. A volcano is a rock thing made out of rock, usually a mountain. Ta-da! It goes up as compared to... What did I just do? I did not mean to do that. It goes up as compared to the rest of the ground, so it's a mountain. Where magma, that's magma. Rock of the Earth's interior made molten or liquid by high pressure and temperature erupts. Here's my erupting. Through the surface. Here's my surface. of the planet. So, a volcano is a rock, thing made out of rock, usually a mountain, where liquid rock erupts through the surface of the planet made out of rock. So I suddenly realized that you guys haven't been able to see my cursor up until now. So I've turned it on so that you can see it now, or should be able to see it now. For today we are studying tsunamis, and I'm going to take you through this tsunami, and yes, I know that the notes are going to be longer than they would be if I was delivering this in class, but that's what you get for getting to watch a video on the destructive powers of tsunamis while I'm not in class. So, introducing, dun da da, tsunami. According to a Japanese folktale, a venerable, which means old and much revered, there's venerable for you, old and much revered grandfather who owned a rice field at the top of a hill, felt a sharp jolt of an earth tremor, which we call a what, class? Earthquake! Yes, we call it an earthquake. That was me. My roommate is being the class today. Felt the sharp jolt of an earthquake one day, just before harvest. From his hilltop vantage point, he saw the sea pull back from the shore. This, by the way, bad. Do not go near the sea when it suddenly pulls back from the shore, as you will later discover. Curious villagers rushed out to explore the exposed tidal flats and collect shellfish, because they were, ladies and gentlemen, what were they? They were...
Shellfish?
No.
Stupid!
Yes! My roommate is slow to catch on. They were stupid! You know, you'd think they live near the ocean. They have to have seen, or somebody old, or somebody in the town, or somebody might have told a story about, you know, these big series of waves that wash people out and said, hey, you know what? When we've noticed that right before these nasty waves come, the ocean pulls back from the shore and exposes huge tidal flats. Don't go near there.
Don't be stupid, kids.
Yes, of course, no, in this story, they went near there. So they're now out in where the ocean used to be and is temporarily not for the moment. I said temporarily, it's coming back. They're collecting shellfish. From experience, the old man knew of the grave dangers to his neighbors. With his grandson by his side, he dashed about his field, setting fire to his crops. The villagers saw the smoke and hurried up the hill to aid their neighbor. They're thinking, what the hell is he thinking? As they beat out the flames, they saw the old man scurrying ahead, setting new fires near the hill's crest. Hoping to prevent him from destroying all of his crops because they figured they were more sane than he, they rushed up the hill to stop him. Moments later, the villagers saw a tremendous wall of water surging onshore, flooding the flats where they had just been standing to collect their little shellfish. And they understood that the old man had sacrificed his harvest to save their lives. You don't get a wave this big unless all the water that would have been here has gone into that wave. Please, please, do not be stupid. The term tsunami comes from the Japanese language meaning harbor, or tsu, and wave, nami. I used to have the cute little icons so you could see what they look like. Hold on 1 second, and let me see if I can find them for you. Here you go. Here's a shot of the PowerPoint presentation that this originally came from. There's tsu, actually. It's more properly pronounced tzu, tsu, and nami. Those are, of course, the kanji kanji being the hardest characters to write. An easier would be hiragana or katakana. So, what we're going to cover in this PowerPoint is Although the term in Japanese tsunami is used for both the singular and the plural, because a tsunami is a series, which is plural. So you could either be referring to a series, which would be one singular word, or the series, which are plural. In English, tsunami, we put an S. We make it tsunamis when we want to pluralize it, to refer to multiple series of waves. This term harbor wave was created by the Japanese fishermen who would return home to find that their entire home, the harbor, had been completely wiped out by a wave. But they weren't aware of the wave anywhere in the ocean, so the wave had to have, in their minds, appeared in the harbor. So, tsunami, harbor wave. We're going to talk about what a tsunami actually is, how tsunami develop, the effects of tsunami types, because yes, that's right, there are more than one, and what are we doing to save people's lives? So what is a tsunami? A tsunami is a series of giant waves. They have a smaller amplitude offshore than onshore amplitude. What on earth does amplitude mean? Good question. We're about to hit that next. Smaller amplitude offshore than onshore. A longer, here's another word we're about to hit next that you might want to star, underline, highlight, cross-reference, draw pictures of, tear your paper so that you know that you can find it wavelength offshore than onshore. They generally pass unnoticed at sea, which is how these fishermen didn't realize that this big, destructive, massive thing was aimed at their homes. And at best, as you're in the ocean, they form little passing hump. There's the hump. I'm going to draw a boat on the hump, just in case you had any questions. There's the hump. Doesn't look like much of a hump, does it? That's the passing hump in the ocean. Looks like it could have just been my bad drawing. This is what happens when it gets closer to shore. The shore is actually right there. Shore. This right here that I just drew in is the amplitude. As you will see later. So, moving on, and please pardon my cats who want to contribute to the conversation. Here is some wave vocabulary for you. We had wavelength before. There's wavelength for you. Wavelength is referring to, by the way, I'm going to draw a wave right here for you. Wavelength is referring to the distance from crest to crest. That's the wavelength. And by the way, we show wavelength with this funny looking, I don't know, like T on its side. So it's like you took the T and you pushed it over and then you made a T on its side. That's called a lambda. Wavelength is measured in things like meters or kilometers for really large areas. So it's the distance from crest to crest, or, and I'm going to try to do this. I don't know if it'll work. It did! It worked! It's also the distance from, now see, trough to trough. How awesome is that? Once again, measured in kilometers. Amplitude is the distance from the top. Hold on, I'm going to delete some of this stuff so that we can deleted as much as I could. Amplitude is the distance from the top of the wave all the way down to the bottom. And that one's also measured in kilometers or usually more meters because this smaller than this. It's all the way from the top to, which is what's called a crest. Crest is the top of the wave, all the way down to the trough, which is the bottom of the wave. And the still water level, which is right here, runs through the exact middle of the amplitude. Well, almost the exact middle. Runs through the exact middle right here of the amplitude. So theoretically, this mess right here is equivalent to this. And this mess right here is equivalent to this. So what is missing from here got stacked up there, and what's stacked up here is missing from over there. Of course, if you're like me, then you certainly know that you suck at drawing and should never draw anything. But here is a much better picture. Wavelength, and they abbreviated it with L, but we don't like L. We like funny T on its side, lambda. Lambda. L-A-M-B, like lamb, like I like to eat lamb with mint jelly. Duh. It should be D-U-H, that would make more sense, but lambda. So wavelength in kilometers, and normally it's drawn from crest to crest because it's just easier to put marks on top of something rather than underneath. Wave height, also known as amplitude, going from crest up here to trough, the height of the trough down there. And then the still water line would be coming in at, once again, Miss L sucks at drawing, at exactly half of that amplitude. So all of this up here should be equal to what is missing from down here. And the still water line, it's not poorly named. Still water line. That's where the water would be if it was still and not in waves. New slide. What tsunamis are not? So we've talked about tsunamis being a series of waves. They are not tidal waves. What on Earth is a tidal wave? A tidal wave is something that has to do with the Earth's tides. When we get into oceanography and we talk about the moon and we talk about some astronomy, we'll learn about things like neap tide and spring tide and high tide and low tide. These have nothing, absolutely nothing. And I just know that some of you on your tests are going to tell me it has everything to do with it. No, it has nothing. I cannot emphasize this enough. Nothing to do with the Earth's tides, even though sometimes they're called tidal waves. It is not a wind action wave. Most waves that you see in the water are wind action waves. This has nothing to do with the winds. And it is not one single wave. It is a series of waves. We call these series of waves trains. So it's a train of waves. What causes a tsunami? The biggest, number one, absolutely most important cause of a tsunami is an earthquake. Second most important cause of a tsunami, and here I am drawing a bucket of ocean. Bucket of ocean. Second most important cause of a tsunami, the sudden dropping of a large lump of earth. It's like dropping a pebble into a bucket. This time we're dropping a landslide into an ocean. Now, more theoretically, this land that we're sliding into the ocean is going to be located over here, and what it's really doing is it's going roll, 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 plop. But that's a mass movement. Landslide, that's massive. It's moving, right? Moving. Mass movement is a landslide. And these landslides can be above water, which means that they're sort of squeezing in our little bucket, or they can be below water, which is our land is going roll, 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 plop into the ocean. We can also have an undersea volcanic eruption, which puts a whole bunch of hot gases and bubbles and stuff squirting all which way up into the water, and that's a massive disturbance of the water, which is, of course, what we had to have as a condition for a tsunami. So we're disturbing the water by dropping a big bunch of landslide in it. We're also disturbing the water, and notice this is undersea volcanic eruptions, because if this volcano was erupting on land, it would not be disturbing the water at all. Undersea volcanic eruptions disturbing the water. And the absolute least likely to cause a tsunami is a large meteorite impact. It would be much more likely to cause death, destruction, mass panic, and some really bad Hollywood movies. So just here for you is an example of an earthquake caused by a subduction zone. So what you have right here is, if I could draw this out all the way, is you'd have some ocean and some continent subducting, and the ocean really wants to go down, and suddenly it shoots the continent up because it finally goes down. The continent goes up. It, of course, pushes all the water above it up. Continent goes up. Water goes up too. Well, all that water now up. Gravity, our lovely theory of gravity. By the way, some of you on your test said that theories could not exist. We have a theory of gravity. The lovely theory of gravity proposes that anything heavy, anything with mass, is going to want to sink towards the center of the Earth. So this stuff is trying to go back down towards the center of the Earth, because it's water, and water is heavy. Just ask anybody who's ever had to lug a large amount of water around. And if you doubt this, because you haven't had to, there is a little plastic sink in the back of my room. Feel free to take it to the bathroom, fill it up with water, and then walk around the school while carrying it. It will give you some really nice arm muscles. Theory of gravity says that this, which weighs something, wants to go back towards the center of the Earth, so it tries to go back towards the center of the Earth, and when it does, it pushes this water out of the way, which then tries to go back, which pushes this water out of the way, which tries to go back, and ultimately you end up with little waves. See how each one of these little crests right here translates to a little crest down there. So it's also going off in this direction, but we don't care whether or not it's going off in that direction because our house is here. So we've got it going this way, and it's pushing, and now this wants to go down, and so this is going to go that way, right into the house, and then we have a disaster. So, again, a less drawn-by-hand version. By the way, I am not responsible for this artistry. That's why it actually makes sense. So, we've got, this is the continental crust, and it's subducting, this is the oceanic, I would fail my own test, oceanic crust, and it's subducting here, and the continental crust over here. You can tell because, hi, there's some continent over there. So this is a continental crust. Oceanic crust is subducting. It got stuck like sandpaper and then jerk. It went down. By going down, suddenly it flips this up a little bit because it's everything in motion, equal and opposite reaction. Water column pushes up, pushes the water up. Water wants to go back down. Water wants to go back down. It now pushes this mess up, pushes down, pushes this mess up. Now it's going to come down, pushes this mess up. And look, that's a little bitty house. What do you think is going to happen to the little bitty house? Big wave, little bitty house. Arrgh. And we have a disaster. And in case you hadn't had enough of it, here it is in animated form. See how it's subducting? The oceanic plate is subducting here. It's subducting and it gets stuck. It's pulling the continental plate down, it's pulling it down, and then it suddenly spits it back out because you no longer have that friction force. And when you spit it back out, that's when it's pushing that water up, pushing that water over, pushing that water over, and badness ensues, and we have a disaster. So, the two types of tsunami. So there are two types of tsunami. By the way, I'm getting tired of delivering these notes, so I know that you're probably getting tired of watching them. So feel free to go ahead and take whatever breaks you need. Remember, this is a video, and there's always the pause button. And depending on what I do once this video is all put together, it might all be one insanely long video of doom, or it might be many short videos. Because right now, the way I've been recording it, I'm on video segment number 3. So there are two types of tsunami. The first one is far field. Far field has the word far in it. It is generated from fault lines of submarine landslides, usually located along other plate boundaries than the one which the coastline is located. This means that it is located far, far away. So a far field tsunami is a far, far away. It's something that started from far, far away. So it's a far, far away earthquake. Or in this case, a far, far away submarine landslide. A near field has the word near in it. I'll give you one guess as to where this is located. It's generated from fault lines along the plate boundaries on the plate that contains the coastline in question, or along deep slopes along the edge of the continental shelf. So it is near or concerning the plate. So, up here I'm going to draw some fake oceanic plates. And I like simple geometric shapes because I can somewhat draw them. If we had a pink. Okay. Okay. That was so ugly, it's not even funny. We can no longer be pink. But I want to be pink. Let's be this one. There's us. We're standing over here. There is a landslide or earthquake going on at the strange splotchy spot. That would then be far field, because it is located not on our plate or on this plate. It's located one over. Now, if we had an earthquake take place at strange little tie-dyed spot, that would be considered a near-field earthquake because it's located on the same plate that we are standing on. You can tell I wanted to use the colors. So a far-field tsunami is often triggered from the Pacific Ocean's ring of fire because of the ocean subduction zones. So here is the Pacific plate. This is some of Eurasia. Get rid of it for accuracy's sake. So Pacific plate. Where is it subducting? It is subducting here and 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 well, look at that. It's subducting everywhere. So now you might ask, well, why do we care that it's subducting everywhere? You know, we know it's subducting. It's called the Ring of Fire. These are oceanic, so this is an oceanic type plate, and all this mess out here, because there's about five different plates. They're all oceanic as well. So why does it matter that this is all oceanic subduction? Or subduction at all? Well, think back to here. When you have subduction, then you get this little springing back thing. Spring. 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 And each time you get a springing back thing, then you get the potential for a tsunami. So, far field, no matter where you are in the world, unless you're living in the Pacific Ocean, far field usually come from the Pacific Ocean's Ring of Fire. Four other sources are Alaska and the Aleutian Islands. They're located up here, like way up here. South America, located off to this side. Especially, there's a subduction zone west of South America between Ecuador and Chile. And those of you who did, by the way, so Ring of Fire is like, switch to a color that shows up on this. There we go, yellow. Ring of Fire. Oh, that's like a highlighter. That's not yellow. Why have you forsaken me, colors of markers? Okay, I know red is hard to track for some people, but we've got to go with red because it's the only thing that's going to show up on this blue. So I said ring, and I kept always drawing it as a ring, and you guys got all spoiled. That would be the Ring of Fire. I've somewhat traced the plate boundaries and I've somewhat drawn it from memory. There you go. There is your Pacific Ring of Fire. That said, it also might come from this area right here, which is another subduction zone. Notice there's a difference in space here. That's because there's a plate that's actually happening right along in here. So there's a subduction zone there in between oceanic and continental. And to remind you, oceanic and continental, spring, yes, the spring ocean causes earthquakes. Then there's another subduction zone off the coast of Chile, right around here. See, this is how much map makers suck. Look, they put it there. It's not there, it's here. The Alaska thing, not here, it's there. This one might be dead on. This one's not. So, of course, you've got another subduction zone here with the little springing. And now I'm going to leave it at red for the moment. So, Alaska, check. South America, check. Then there's Tonga. I can't even begin. Kermadec. By all means, if you know how to say it, please do. Please correct my pronunciation. There's a trench there. That's somewhere around in here. You can't really see the trench from this map. And last, somewhere in the northwest, again, I'm not even going to attempt to say it, Northwest Pacific from Japan to east, and I can't say that one, which is up around here. So, those are all also subduction zones. So, subduction zones. And then you can see these little bands that are radiating out. This is actually trying to predict how many hours. So if we have one that starts here, in an hour the wave is here, 2 hours the wave is here, 3 hours the wave is here, 4 hours the wave is here, 5 hours the wave is there, etc. And then, oh look, they're hitting Australia and New Zealand at about 17 hours. If Alaska springs one, it's hitting Australia and New Zealand at about 17 hours. They didn't bother to do one for these. But this actually came from New Zealand, New Zealand's website, or the New Zealand Geological Survey or something's website, and they felt the need to let you know, or let us know, that drat those North and South America people, those of us in the Eastern Hemisphere, 17 hours later, they get stuck with our tsunami. We need to stop having tsunamis. A near-field tsunami can be set off by earthquakes occurring close to the coastline. So, if this is our coastline, and we've got a subduction zone going on right here, this one's going to make a near-field for us. By the way, the same earthquake can be both near-field for some people and far-field for those chilling out in New Zealand. So, earthquakes occurring close to the coastline, so Alaska gets a near-field tsunami when 17 hours later New Zealand gets a far-field tsunami. A deep-sea landslide, that would be, here's my coastline, and now I'm going to go down and make my little ocean. And here's my boulder. It's going to go plop. So roly, 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 plop, splash! There we go. Deep sea landslide just off and this mess right here. Continental shelf. We'll get into this when we talk about I can't talk and write at the same time. This mess right here, we'll get into talking about it when we talk about oceanography. And finally, a near field would also be, if unbeknownst to us, we have a volcano and it spews right off the coast. How noticeable is a tsunami? You guys will be able to answer this question for me after watching the video that has been left for the sub. My cat's talking. Can you hear him? His name is Tequila. I have another one named Jordan. Jordan is sitting there quietly eyeing everything that's going on and thinking Tequila has done gone and lost his mind. Meow. Meow. Tequila is quickly going to take over doing the presentation for the remainder of the time. I hope you all speak cat. Oh, Jordan went and quieted him. So how noticeable is a tsunami? I should certainly hope that you would notice the leading wave comes crashing onto the shore, big whoosh. You know, I certainly would notice something like this. Big wah, big monstrous handy wave of death and doom and destruction. However, as we said before, a tsunami only resembles this big onrushing series of waves. I keep saying this, I'm going to keep saying this, series of waves. It only looks like these big onrushing series of waves, this endlessly onrushing tide, these walls of water that just won't stop dousing my little house, my poor little house, bad, that gets all the bad and the disaster that happens to it. Why, oh why, do these waves come at my house? Oh, why do these waves come at my house? That is a horrible, horrible illustration. You notice that the leading edge resembles a breaking wave, as was seen in Jordan, stop eating my pen. As was seen in this breaking wave. You see it, you notice it. Looks like an ever onrushing tide, and you can tell about the effects of a tsunami because they can be horribly, horribly devastating, or, depending, they can be unnoticeable. But, as we illustrated before with my little bump, there's my bump, out in the ocean, you hardly notice at all that this is going to turn into the killer series of waves of doom. There's my killer series of waves of doom. And there's my little house. You guys should try drawing a house that gets killed in a tsunami. It's quite therapeutic. Ah, death and bad. So, here's how you, those of you who might ever be in a tsunami-prone region, can tell that there is a tsunami approaching. First of all, if you feel an earthquake, do not go anywhere near the ocean. That's right, ladies and gentlemen, if you feel an earthquake, do not, I repeat, do not decide that now is the time to go and swim. Earthquake, big enough that you can feel it, generally results in bad in so many, many forms. So the last thing you want to do during a situation in which there is bad is go swimming. Large quantities of gas may bubble to the water surface. The sea looks like it's boiling. Again, if the sea looks like it's boiling, which it isn't, it's more like the sea is depressurizing. Somebody opened the bottle of sea soda and all the bubbles are rushing to the top. And this is usually caused because there is a volcano happening under the water. This is one of those subsurface volcanoes. Well, not only does it spit out molten rock, but it also has little gas bubbles in it, and the little gas bubbles go up, and they make the sea look like it's boiling, even if you don't remember that the sea is not per se boiling. If the sea looks like it's boiling, don't go in it. For the same reason you would not jump yourself into a boiling hot pot of water. That is just one of those things that should just register as do not do. So, Earthquake is felt? Don't go swimming. Sea looks like it's boiling? Haha, don't go swimming. Sea looks like somebody had a little fart that they let go under the water, only somebody being a gigantic giant. Again, don't go swimming. The water is unusually hot. Again, boiling, hot, why would you go swimming? Don't go swimming. The water smells bad. Bad like somebody has let out a gigantic fart. Don't go swimming. The water is caustic. That means it burns you. If the water is burning you, ladies and gentlemen, I hope that you will get as far away as possible from the thing that is causing you pain. And strange noises are coming from the ocean, usually preceded by a big boom. If the ocean is making a big boom, this is not the time that you are going to be the villagers in that old man's village who are going to go down to that big, all of a sudden, dry bit of beach. Because, after all, to get a gigantic wave, all this, which used to be water, has to go over there, which results in a very bad drawing. No, which results in dry land. Because all that water now built up into this wave that is a-coming towards you. So all the water now in the wave. Look at all the dry land. Totally time to go and collect shells, right? We have felt an earthquake. We see the ocean farting and boiling, and it's hot, and it smells bad, and it's burning us, and there was a gigantic boom. I want to collect shells. I don't know about you. Signs of an approaching tsunami. So the sea recedes a considerable distance. Again, you can't get a big wave without water, and the water has to come from somewhere. So the sea is receding because all this water is all of a sudden getting sucked up into this gigantic wave so that it can come and crash on my precious little house. Also, you see a flash of red light near the horizon. I don't know, and I've been looking for research to explain to me why the flash of red light, but it has been reported with tsunami cases. People have said, I see a flash of red light, I'm near the horizon, or out near the horizon, and then a tsunami wave has come, so you know what? If you see a flash of red light while hearing a big boom, while the ocean is smelling bad, burning you, being hot, and looking like it's boiling, and oh, by the way, you felt an earthquake, and all of a sudden there's a whole bunch of extra shell collecting land that suddenly appeared in front of you, that would be your sign that a tsunami is approaching. Now, this is the same bit of coastline for both a normal wave and a tsunami wave. Here's the thing. The tsunami wave is not necessarily taller than the tallest normal wave that would come. In other words, waves caused by the wind, like I said, most normal waves are wind waves. Waves caused by the wind can, not usually, but can have a very large amplitude compared to the tsunami amplitude. What it is, though, is there's a wave. It's kind of small. This is, of course, wavelength, right? Small wavelength. Small wavelength. We don't even know where this wavelength ends. This is a crest right here. You so cannot see that. Okay, switching colors. There's a crest right here. Remember, wavelength is measured crest to crest. So there's a crest, and here's a crest. So we can already get ourselves a lambda value. Well, there's a crest. Do you see another crest? I don't see another crest. So we've got something coming from here and going that away. That's why we say it has a really long, wow, my lambda sucked, a really long wavelength. Because it's like going and going, and I didn't see any. Look, there's a trough. That's quite obvious. That's a crest, that's a trough, that's another crest. If this is a crest, which it has to be, it's the highest point on the wave, we're going to need a trough before we can even hit another crest. I'm seeing this solid wall of water. This is what makes it incredibly dangerous. It's not that it's taller than normal waves, it's that its wavelength is so much larger. And when you have so much larger of a wave, you have so much more water. So, warning signs and prevention. Warning systems against tsunamis exist, but they're still being developed. If the leading edge is a trough, then the ocean is going to recede. So, waves are made of these crests and these troughs. A wave actually, if you were going to find the wave specifically, so the wavelength is crest to crest. If you had to take a pair of scissors and cut the wave out, you would actually cut it out like this, so that you got it all the way down to its halfway from the first trough, all the way up over the crest, all the way down to its second trough. So, that said, either the crest can come first, or the trough can come first. Generally, the trough comes first because the crest follows behind it. So if the leading edge is a trough and the sea recedes, because all of a sudden we've got a low point because all of the water, all of this water has to go up here to make this crest, then nature is offering her own warning system. Do not go pick up shells. If the leading edge is a crest, so sucks to be you, this is what's coming at you. There was no trough in this picture. It's just a wall of water. Again, nature is offering its own warning system. It is just a sign of things to come. You've got a solid wall of water coming at you. Do you think that there's going to be a lot of water coming? I do. And the most important thing that you can do to prevent loss of life, you cannot prevent a tsunami. Preventing a tsunami means stopping all the convection cells and the convection currents that take place in the asthenosphere. So you absolutely cannot prevent a tsunami. However, tsunami education prevents the loss of human life, which is the thing, because we're narcissistic little species, that's the thing we most are concerned about, is the loss of human life. And, tsunami education, which is what I've been trying to do with you by saying, do not go to the ocean if you suddenly find yourself with extra beach, and do not decide to take a swim when you feel an earthquake, and if the ocean looks like it is just let a doozy go, and it smells like one too, and by the way it's hot and all bubbly, do not go swimming. And if you hear the ocean go boom, do not go swimming. And if you see a flash of red light in conjunction with the ocean going boom, or it having farted under the surface of the ocean, or the ocean burning you because it is caustic. Where is it? There. Or the ocean burning you because it is caustic. That's what we call tsunami education. That one was Jordan. He's just suddenly decided to start talking. He wants a piece of this action. Do not go swimming. That will keep you alive. It will prevent the loss of human life from going to the shore to see a tsunami in action, ladies and gentlemen. It's a gigantic series of waves. You can look at little bitty waves and then just think, what would this look like if it were big? And that would answer your question. Tsunami warning systems. There are computer-based prediction systems that tell you the time of landfall. These computer-based prediction systems are the kind of things being used here so that New Zealand can figure out the time of landfall. Basically what it does is it measures the kind of the warning earth tremor wherever it was for far field. This is, by the way, for far field. For far field tsunamis. It measures the tremor, the thing that sets off that tsunami far field, and then calculates how long it's going to take to propagate, which is nothing more than propagate is travel or move. For waves. This is very important for waves. Oh, well, it also, you propagate a rumor to travel or move for waves. That's how long it takes them to, they can calculate how long it'll take them to propagate up to the coast of poor New Zealand, who seems to be the most hateful of Alaska out of them all. There are also computerized warning signs. I don't know if any of you have seen the computerized warning signs on places like I-40 where it says, in nice, big, over-the-highway letters, it says, test. And here are the little cars going beneath it. See, now that I drive, I'm very attuned to this stuff. There's a little car. It's driving under the sign which is saying test. Sometimes these signs say things like slowdowns expected. Mind you, we're usually stuck in bumper-to-bumper traffic. Or for more information about traffic, call the following number. When you keep hearing that talking on your cell phone while driving is a very bad idea. But there are computerized warning signs that inform the public where to go for shelter. So this is at least a little bit more useful than test or saying, there is a tsunami happening. Instead it says, for shelter, go to higher ground. The following places are tsunami shelter locations. The most important thing to do, if you're ever planning on going somewhere where it is tsunami prone, watch your nearby most beloved pets and animals. The last thing those animals want to do is get whacked with a tsunami. Animals are instinctually very smart. They'll start digging, the little mices will start digging for shelter, and everything will quickly vacate. The birds will disappear. It will become strangely, eerily devoid of life when there's a tsunami. And here, just for an example, is an example of the destruction caused by the 1998 tsunami in Papua New Guinea. Bet you didn't know there was a 1998 tsunami in Papua New Guinea. That was a village. 'Tis not anymore. Tsunamis, for being a whole bunch of water, are very, very destructive. This is an example of a tsunami warning chart, or like the thought process, the decision-making process that takes place before an organization like NOAA, the National Oceanographic and Atmospheric Association. And before you think it's spelled NOAA, it's NOAA. National Oceanographic and Atmospheric Association, NOAA. See, NOAA, NOAA, NOAA. This is not NOAA. This came from somewhere else, but this is a tsunami warning system chart. There's a major undersea earthquake, magnitude 7.0 or greater. Remember way back in the slides, and I'm going to try and find it now. Some quick vocabulary. Here we go. Earthquake. An earthquake of Magnitude 8 or larger is termed a great earthquake. So in this flowchart, there's been a magnitude 7 or greater. What they're really looking for is, was it a great earthquake? See, this is why we have that term great earthquake. Yes, we've got it measured on seismic, which means of and pertaining to earthquakes. It's an adjective, so it's measuring equipment, earthquakey measuring equipment. We see there are different sea level instruments saying, oh my goodness, there's a massive quantity of water swept out to sea. That would be the trough. NOAA, tsunami. Oh, excuse me, I'm yawning. By the way, take a nap right now. Pause this video, take a nap, then wake up and keep going. NOAA has these tsunami detection buoys. They can measure, and you'll see it in the video, they can measure earthquakes happening underneath the sea. Jordan, stop eating my pizza. They can also measure the water level. So that goes to the tsunami warning centers. I told you to stop eating my pizza. Don't make me throw a CD at you. There are 2 tsunami warning centers. There's one along the west coast of near Alaska. Remember how New Zealand's not too fond of Alaska? Well, we're measuring things there. It's in Palmer, Alaska. The other one is along the Pacific because, well, Ring of Fire, do-do-do-do-do-do. I'll play you the song as soon as this video is done. That's in Hawaii. They analyze all this data coming in, and then they issue a, more importantly than anything else, they issue a near-field tsunami warning for areas close to the earthquake. Only for locations close to the earthquake. Otherwise, before they issue a far-field tsunami, they'll say, did we get a tsunami? Now, it is entirely possible that you have a boulder that falls into the ocean that does not result in a tsunami. If the tsunami was not generated, then the tsunami bulletin says, no tsunami was generated, and state and local emergency management officials get to read the bulletin that no tsunami was generated. And for low-lying coastal areas, they might still evacuate, because even if there wasn't a tsunami per se generated, there might have been one, because a tsunami is a series. Tsunami is a series. But there might have been one very big earthquake, or very big wave, so they might still evacuate. And you'd get your information from radio, cable, TV, and then the general public would find out upon watching the radio and cable TV that they've decided to evacuate the areas, because state and local emergency officials found out there wasn't a tsunami coming, but there might have been, a big wave that was listed in a tsunami bulletin that came from NOAA, one of its 2 warning centers. They came from either seismic measurements, detection buoys, or sea level instruments. So we've got general public, this is done, this is done, this is done, this is done, this is done. This we started with, done, 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 done. We talked about this, near field, only for those close to the earthquake. The National Weather Service will activate the emergency tsunami watches and warnings via NOAA weather radio, and everybody with a radio receiver will find out about it, and then the general public will panic, or there will be an all-hazard alert. And by the way, the school has an all-hazard alert radio which goes when something bad is coming. Then it will alert the general public. So, if a tsunami is generated, we've gone with no. Yes, a tsunami is generated. Then they will continue to expand, NOAA will, the tsunami information bulletins, tsunami advisories, watches, warnings, and for respective areas. This is for far field, by the way, because let's face it, New Zealand had a 17-hour wait time for that tsunami that was near field to Alaska. So during 17 hours, you can try and pinpoint where exactly it's going to hit. Damage prevention. Now, you will see this in the video. In order to prevent damage from this tsunami, Japan has built walls in front of its little sea towns, in front of its little populated areas. There's a little wall that's in Japan. It's built. Other countries have built floodgates. We call them in New Orleans levees. Drove a Chevy to the levee, but the levee was dry. Other countries have built floodgates in order to direct the water away from human settlements. But let's talk about these damage prevention mechanisms. So we have this seawall right here. Well, one of the problems is that tsunamis are often higher than these seawalls. The actual thing that does the most good are tree covers on shorelines, because as the water is rushing in, it's like the Japanese game pachinko, where it has a whole bunch of little pins and you have these little balls. As the water is rushing in, it has to break up to make it through these trees, and that cuts a significant amount of its destructive force as opposed to the water rushing in, and here's a little seawall, and you've got that kind of a wave coming in. Well, guess what? Your little person over here, screwed. But your little person who's standing over there, and see, this is a top-down shot, so you get to see his little arms in the top of his head, not so screwed. Also, for the same reason that trees help break it up, offshore reefs, which are rough and have lots of little holes that the water has to go through, offshore reefs also help break up the destructive series of waves. And last but not least, a large number of references that you might want to avail yourself of at some point. I am leaving it here. It will be on the PowerPoint. Learn it, love it, watch it, get excited about it, and I will be collecting the notes that you have taken based on this online video lecture, on disc video lecture, on the computer video lecture thing. I will be collecting your notes when we get back to school on Monday. So please, please, please make sure that for Monday you have taken notes. Even if what it means is printing out the PowerPoint and jotting a whole bunch of different things, I am absolutely going to be looking for your vocabulary. Absolutely will be looking for this quick vocabulary. I will be looking for it to be done in this format. Absolutely the vocabulary. I'm hoping to see somewhere repeatedly that you've got this idea that the waves are a series of waves. I want to see that you've got the wave vocabulary down, that you've got lambda and you've got the amplitude, and that you know the trough and the crest. I'm looking to see that you've grasped the concept behind this animation. And by the way, if you don't have this concept, it is in the PowerPoint. It looks like a still picture in the PowerPoint, but the instant you go and turn the PowerPoint into a presentation by pressing the little presentation button right here, see, slideshow. This is what it looks like. Not very impressive. Press slideshow. Ta-da! Now it starts moving. Absolutely have that concept down. Very, very vital concept. When this thing goes sproing back into action, puff, puff, sproing, it's going to thwack the water above it, and that could cause a tsunami. Know the difference in between near field and far field tsunamis. Near field means it happened right next door. Far field means it's going to take a while to get there. Make sure you have taken notes on the video, and check out some of these references, because when we come back, this is, of course, the Destructive Seismic Events Unit. We will have gotten rid of tsunamis. We'll be start chatting about